live on Facebook, which is fantastic. So good afternoon, everybody out there, and welcome to the first of what is planned to be more of these GSO Ocean Classroom Live events, where we're hoping to connect all of you out there to ocean scientists and other scientists that are doing really interesting work, as well as educators that are using that data and knowledge in their classrooms, and then sharing some important details, knowledge, and taking your questions in real time. My name is Holly Morin. I am a marine biologist and a science communicator with the Interspace Center at the University of Rhode Island's Graduate School of Oceanography in Narragansett, Rhode Island, and I'm going to be your host today. Today's GSO classroom is going to focus on the Arctic, and I was very lucky to have sailed through the Arctic last summer as part of the National Science Foundation funded Northwest Passage project. So we're going to talk to you all today about the Arctic sea ice, the Arctic ice, the seawater, and the connectivity between those two features, and maybe get into a little bit about the interdependencies between the ecosystems and the animals that live there in the Arctic, and then the connectivity between the Arctic itself and the whole globe, and how changes that are happening in the Arctic impact even those of us that live right here in Rhode Island. And this focus on climate and changes that are happening in the Arctic, it actually resonates really well with the theme for our upcoming Earth Day. So Earth Day 2020 actually happens next week on April 22nd. It'll mark the 50th anniversary of Earth Day. And this is a time for all of us to really take a pause and think about human impacts to the Earth and how we might be able to make small or big changes that then will have a positive impact on the Earth itself. So like I said, Earth Day 2020, it's climate impact. Climate's something that can actually be a challenging dialogue to have, but not today. We want to involve you all in this conversation. We want you to be part of this conversation. So definitely type in questions that you're having throughout this whole Facebook Live event today. You can type those right into the comment feature that's underneath the video viewer, and those will then get filtered back to us, your speakers today. So getting to our speakers today, it's not just me that's going to be talking to all of you. I am actually joined by two other individuals that have also sailed in the Arctic and have fantastic experiences to share with you all. So Alessandra D'Angelo is a chemical engineering postdoctoral student here at the University of Rhode Island's Graduate School of Oceanography. And then Kathleen Couchon is a high school teacher at Narragansett High School. So I'm going to actually let them introduce themselves and share a little bit about their experiences in the Arctic that connect back to these fantastic pictures that we're also going to be showing. So Alessandra, say hello.
Yeah, hello everybody. I'm Alessandra D'Angelo and I'm a postdoc at University of Rhode Island here at Graduate School of Oceanography. My postdoc is on chemical oceanography and my background is very interdisciplinary because I was studying in Italy because I'm Italian, and I was making a bachelor in environmental science. Then I was attending my master degree in marine science. And then I was, my passion was always studying the poles. And so I was attending my PhD in polar sciences. So it's from 2013 that I'm studying the Arctic, and I was very lucky to make several campaigns in the Arctic. And so I think, the most important thing for me and maybe the powerful thing is to have a very wide background. And so this can allow people to understand much more this multidisciplinary work, because polar sciences is not just just a sectorial part of some sciences, but it's involving more or less the whole science. And this is very great, I think, because you can understand a lot of dynamics. And also, this is the point for the new generation, I think, because it should be very nice to understand if kids today, the new generation, really understand this importance and really feel the importance of preserve our environment and above all the poles that are very vulnerable. And so now I'd like to listen from Kathleen Couchon, that she's an educator. And so I'd like to understand much more this aspect of the of sciences, because we are scientists, but it's the most important thing, I think, is not only make research by itself, but it's also to let people understand and to involve people in this kind of fields. And also, just briefly before going to Kathy, I'd like to let you understand what's a postdoc. Background, because maybe not everyone is familiar with this kind of people, because in research there are several steps, and so once you get your PhD, it's very important, if you want to make research, of course, and you want to stay in the academic field, to attend your postdoc, that it's a sort of job, but also you still continue studying, and your research is involving in something bigger. And so it's I think it's a connection of efforts made by scientists and also by educational people. And so this is for me, it's an amazing opportunity to stay here and to attend this postdoc. So now let's talk to Katie.
Thanks, Alessandra. All right, so this picture, you can't see the background because it's all white, because that's what it's like there. So I'm Kathleen Couchon, and I am a science teacher at Narragansett High School. I teach mostly freshmen and sophomores. I've been there for about 20 years. When I went to the Arctic, I was actually a middle school teacher, and I was teaching 7th grade. I had the great fortune to go to the Arctic with the help of the University of Rhode Island and the National Science Foundation. And as you can tell from the picture and looking at me now, this was a few years ago. I know Alessandra was just there recently. But I was there a few years ago on an ocean drilling expedition. I had never been on a ship before. I had never, I certainly was never away for 6 weeks, away from my family and away from everything that I knew. But it was an education for me. And as a teacher, this picture, I'm talking actually to my students back in the 7th grade by satellite phone. So we had a chance to converse with them, and they had a chance to ask questions about what was going on. Like we hope that students and people will ask us questions today about what's going on. So climate and the polar regions are things that a lot of people have difficulty working into the classroom, but I think in teaching earth science and biology, there's so many points that you can jump off and delve into polar science. Honestly, if I had the chance, I would spend the entire year talking about it, but that's a little difficult. But I do find that students, and I know Alessandra was alluding to this, are really interested in what's going on with climate, and they're intrigued by the polar regions because a lot of people don't get to go there. I mean, we're fortunate that we were able to go there, but there's lots that we can share in the classroom. And I do think that students today are interested in what's going on and interested in making a change, you know, in their world. So Holly, I'll send it back to you. And
great. Thank you, Kathy, and thank you, Alessandra. Kathy, what you're talking about with questions, I think that's a great reminder to everybody out there who's tuning in live right now that as the three of us are chatting, if you all do have questions, definitely type those in. And those can be anything about Arctic science research, the Arctic environment, et cetera, and we'll do our best to answer those today. My experience with the Arctic, like I mentioned, comes from when I was sailing with the Northwest Passage Project. And I think it's really fantastic to hear a story of a scientist and now of a teacher that has sailed on board the vessel. And it shows you how many different people can actually go out to sea, even though we're not all necessarily scientists. The Northwest Passage Project was really interesting in that we had scientists and filmmakers and undergraduate students and graduate students, a really multidisciplinary group that were participating in this project. And when I was asked, you know, go find a picture of your experience that really resonated with you, this was the one that I thought of, and this was actually when we were in the Arctic. It was July, so the sun never set. It was the land of the midnight sun, as they call it. This was about as dark as it would get. So I think this was about 2 o'clock in the morning, and this was as low as the sun would get, right above almost the horizon, and then it would go right back up. But it was cold, and that's I should have had a jacket on, and I didn't. And I remember I was about to go back inside, and somebody was like, "No, no, no, you need to just stay here so I can take this picture." And I'm so happy that I did, because it just was a really great moment. And one of our students recently said to me, reflecting on their experiences up in the Arctic as part of the Northwest Passage project, is that you were just present. And that's really true.
Mhm.
I think when we were out there, yes, it's very remote, but it was so incredibly quiet. It was beautiful. We were all focused on our different facets of work, but also sharing that with everybody. And you were really, I think, just aware of where you were and how special it was. And that was one of those moments where I was actually outside just taking it all in when this picture got taken. So it was a really great experience. And actually, Kathy, just to tip it back to you, you're out there on the ice like that. You're a Rhode Island middle school teacher at the time. What was it like when you first saw the ice up in the Arctic?
It was amazing. I think it's kind of interesting, and I don't think anyone said this before, that the three of us actually traveled on the same Swedish icebreaker.
Oh, that's right, yes.
So we were all sailed on the Odin, which is premier among icebreakers, and I think you would both agree with me. It's just a fabulous ship.
The logo was saying that it's the best icebreaker in the world.
Yeah,
Probably the best icebreaker.
I have my Odin t-shirt on underneath my
yeah, me too.
And that's exactly what it says, that it says the best icebreaker in the world. And I would completely agree.
Right. I think we all have the same shirt. That's great.
Probably maybe in different colors, but yeah.
Maybe.
For sure.
And so it's so cool to look at your pictures too, but I think we were all out walking along the deck as we got up to the ice, because you get so excited when you see this one little piece of ice float by and you think, oh my gosh, we're in the Arctic. And you have no idea that when you get there, it's just going to be this extreme environment of ice everywhere. So ice was really important to what we were doing up there, because I was on an ocean drilling expedition. And so when they need to drill in, we were drilling into the mud below the Arctic Ocean, which was the first time they'd done that in that region of the Arctic. They've drilled around the perimeter, but we were only 150 miles from the North Pole on a ridge that they were drilling down into. And so to drill through water and into mud is a challenge in itself. But when you have to go through an ice surface that moves, that adds a whole other dimension. So what we needed to do was, in my picture when I'm on the ice, we were actually out there putting out little satellites, reflectors. And so we took a helicopter ride out there, landed on the ice, and then we spent about an hour putting these little reflectors into the ice so that when satellites would go over, they would take pictures of them and they could see which way the ice was moving, because it was really important to keep the ice away from the drill apparatus.
Fantastic. And then I think what was being shown as well, so we were, and this is something else to point out to folks, is that we were in different areas of the Arctic. You want to remember that the Arctic is actually, basically it's a frozen ocean. So that's one of the reasons, or one of the differences between the Arctic and the Antarctic, where the Antarctic is a frozen landmass or continent. So we were in the Northwest Passage. We were in an area called the Canadian Arctic Archipelago, where Kathy, you were much further north into the actual true Arctic,
yes,
up by the North Pole. So you were looking at sediment samples, and I think one of the pictures that came up was actually showing the ice core. So something that we were looking at was actually, in addition to looking at features in the water column, we were looking at ice core samples. And Alessandra, this picture here shows that. And I know this is something that you and then Dr. Bryce Luce, whose lab you're in at GSO, you were all looking at. I did not go out on the ice. I was happy to let the students go out in the helicopters on the ice. I know you were leading. So if you want to share a little bit more about those experiences, Alessandra, and that would be great,
sure.
what's shown here.
Yeah, it was very amazing because I mean, usually I was sampling water. So in the past, I've been several times in the Arctic, and I was usually sampling water or samples from sediment traps. But this was my first time in the helicopter, just to reach the good spot to sample. So it was very, very fascinating. And here the picture is showing the ice core, because when we decide to, we may make a plan of the sampling according to your investigation. And so, you know, if you want to sample multi-year ice or first-year ice, and you decide the good spot that you can land on and can sample, and you go by the helicopter, you land on these very small blocks of ice. And it's very, very, very challenging. And once you get on the right spot, you start to make some samples according to some sites that you want to see, you want to study. And then here, this is the ice corer, the orange one. And you can see that in the bottom, it has a very sharp, it's cutting very sharp because it has to cut the ice that many times it's very resistant. And here, once you get this ice core, you have to lay the ice core down in a very clean environment, and you have to cut the in slices according to your research. So you want that, usually we cut each 10. And once you get the core ready, you put the core, bring the core. Yeah, here we're just showing the activity, how you have to drill, because it's very challenging to not break the ice core and to not break the ice corer, of course, because we have been in a training course in Finland, and unfortunately the ice corer was breaking. So it depends how strong you push on the drill and other factors. So here you can see that you have to go straight down in the ice, and once you get the core, you have to not lose your core while you are pulling the ice corer, and you have to put the, as you see in the last step, you have to put your feet below the ice core, because you don't want to contaminate your ice core, of course. So once you get the ice core, it depends from your purpose, but we were sampling for methane research, because we want to investigate the amount of methane in the sea ice, and we were coring for microplastic occurrence. So according to these two investigations, we were melting the ice on the board, and then we were proceeding with the processing of the ice core.
Fantastic. And I think it's interesting when you look at the ice core itself, you know, it's attached to a hand drill, modified hand drill, if I remember correctly. But Kathy, the drilling that you were doing when you were out there was obviously ship-based, so it was a little different.
Right. So we had, well, you have this one apparatus to drill a core. We had an entire ship, an icebreaker that had been refitted with a drill apparatus on it. And that's where the drilling happened. So we had actually 3 ships in the expedition, the drill ship, and then the Odin worked to break up ice right around the drill ship. But we also had a Soviet nuclear powered icebreaker, much larger than the Odin, that broke up the big ice, the multi-year ice. And so it's interesting to see the core and the difference. So we had mud, Alessandra, you have ice, but both of those are used for to study past climates, climate change. And that's one of the things I like to do in the classroom, is to talk to the students about the technology and to look at some of the data in the past that shows what was the climate like and how do we know that? Because I think that's so important for the students to not only know the facts of what's happening or what has happened, but really to know, how do we know? You know, how do people figure that out? And so to bring back information from expeditions like these is huge for students of any age, to tell them, oh yeah, we know this is true because we have evidence.
Yeah,
So
sure.
we've investigated this. So I think
we're
there's a
getting some
picture, there
questions
might
from
be
everybody
one
that's
of
watching, which is great. Keep
the
those
mud
coming in.
core. I don't know if you can pull that up or not.
Oh, you have one of it. I don't know, Derek, if you can find the picture of the sediment core, just so folks can see that compared to an ice core.
And the technology was drastically different.
Yeah.
Nope. Oh, we're going through all of them. Oops, maybe not. There it is.
Yeah.
So this is on the drill ship. And so what they're doing is they're cutting them into, I think, meter long pieces. And then they would store them in a refrigerated, funny, right, in the Arctic, but you still have to refrigerate them.
Yeah.
And then half of the core would be archived to save, and then other scientists could call in to where the sediment core is stored and ask for samples for their particular research. So it wasn't just the people on board the ship who were interested, but there's a whole group of scientists who study climate and past climates who would be really interested in the mud samples.
So in addition, so we're getting some questions from folks that are viewing, which is great. So in addition to looking at sediment cores and looking at the ice, which one clarification to let you all know, when we're talking about multi-year ice, that is ice that did not melt during the summer. And so it builds up as layers. So you can actually see those layering in ice. When you think of Arctic sea ice, it's actually not like an ice cube, the smooth, see-through type of block. It's actually has a lot of fissures in it and channels and different layers, just actually kind of like a sediment core. So one of the questions that everybody's asking is actually if we saw any animals. Kathy, I don't know where you were so far up into the Northern Arctic, if you all saw any animals when you were out there in more of the solid ice flow. I know, Alessandra, we saw lots of animals.
Yeah, we saw a lot.
Yeah, we were, and I don't know, so they actually would always put out polar bear guards when you all went out in the ice, so that you didn't see any polar bears when you were out there. But from the ship, we saw several polar bears. We saw bowhead whales, narwhals. The film crew, when they were going out, so there's a film crew producing a documentary. They went out, they had seen walruses. So a lot of diversity. I think we were really actually quite lucky in the diversity of animals we saw. But Kathy, did you see any animals when you were out on your trip?
We saw walruses and we did see polar bears. In fact, when the ship was anchored for a bit, or when we were kind of just stationary, it was interesting that the polar bears would all come around, because then you could see them sniffing for all of the aromas coming from the ship, which I think you'll all agree, the Odin had fabulous food.
Yes. Yeah.
Yeah.
I was wondering what we ate. I don't know, Alessandra, if you want to allude to, a lot of times we get asked, how was the food on the ship? How was the food in the ship, Alessandra?
Yeah, I mean, I'm Italian, so you cannot ask to me how is the food. But no, of course, on the ship it was very, very good. And also one day he was making lasagna, and the lasagna was very, very good, I have to say. It was a Swedish lasagna, but very, very good. So yeah, no, I have to say also a lot of different kind of receipt and different kind of food. So, and also there were vegetarian and vegan people on board, and he was taking care of every one of them. So it was great. Yeah.
This is actually footage of the ship from the outside. This was drone footage that was shot by Dr. Donglai Gong with the Virginia Institute of Marine Science. He was a physical oceanographer that sailed with us as well. And it was really beautiful footage there you can see of the ship. A lot of folks are actually asking if the ship got stuck. So Alessandra, I think they might actually be thinking of another project that you're associated with, which is a big project. You might want to share
we did get stuck a couple
with that, folks, about that.
Yeah, sure. So this ship was not stuck, I mean, intentionally, because we were just crossing the Lancaster Sound. So it was not supposed to be stuck, and it was going very, very good on the ice. But there's another ship that is stuck in the ice from September. And it's the Polarstern. It's a German icebreaker, and this project is a huge project in the Arctic. I think the biggest one ever recorded. And it's called Mosaic Project, Mosaic Expedition. And it's about 1 year long dataset collection of each kind of research. And they were stacking the polar stern in the central Arctic. And now the polar stern is moving by the ice flow, so the sea ice flow. So it's drifting and it's going very, very, I should say, faster and eastern than the forecast, but it's going great and people on board are still working. And it was, of course, a little bit impacted by this uncertainty that it's around because of the coronavirus. So I was supposed to be on board in April, but I'm still at home. So we are just waiting for some good news, and hopefully we are going to exchange very soon. I mean, soon in maybe 1 month, who knows? And so that the project can still go on, even if there's so much uncertainty around, because I know that a lot of campaigns were canceled and were not possible to be done because of this problem. And so, yeah, so I mean, when you study in the Arctic or in Antarctica, it's a little bit challenging because the environment is very extreme. And so usually you have a lot of troubles to arrange a good maintenance of instruments, a good research sampling for the whole year. And now it's even more challenging because everything is locked. And so
yeah, I think when you think of the current, what's going on with COVID-19 and how it's impacted all of us, folks may not be aware that, oceanographic cruises that may have taken years to plan have now been postponed, or, and it's exactly what you're talking about, Alessandra, is it's not just you go out in a boat and you go out and you do your work, you have to physically get to that vessel. The vessel usually will not go back to the same port. It might go to a different port. And then you have a change of personnel. So it's a lot more complicated. And that's a puzzle that's going to have to definitely be pieced back together for not only the Mosaic expedition, but for a whole host of other oceanographic research expeditions that have now can kind of put on hold and are on hold for the next several months, which you were just talking about. Kathy, your ship was stuck in the ice because you were so far up in the Arctic that's why the Odin was with you, or you had another icebreaker with you, or those 3 ships. Right. Because of the fact, I mean, you have actually the picture. If I remember, I was looking at your pictures and you're actually out on the ice. Our group was taking helicopters out to multi-year ice flows, but it seems like your ship was right there in the thick of it, kind of like how Mosaic, the Polar Stern, is right now.
Well, we were not supposed to be stuck in the ice because our job was actually to break up the ice. But there were a couple times when, well, I should say I was fortunate to be on 2 different expeditions. So the first one was the ocean drilling. The second one, we were in a little more open water because we were testing autonomous vehicles that could go out under the water. And as it was described, the scientists knew that they could send this vehicle out under the ice, but they didn't know if they could get it back. So that was the big test that we were on there. But on the first expedition, the drilling one, when we were breaking ice, that was our goal. There were times when the multi-year ice was so thick that the ship would get stuck there. And so if you were in the thicker ice, you remember the vibration of it, and you got used to that. It wasn't a rocking at all on the ship. It was just a steady vibration. And you got used to that. And so when the ship stopped and the vibrating stopped, even if you were half asleep, you would wake up because you knew that was different and that was wrong. And so we spent some time backing up, going forward, backing up again to get out of the ice.
Yeah, that's what actually on the ship we had, where we had gone as far west as we could. Derek, I don't know if there's actually a picture that says multi-year ice that I had. That's exactly what happened. We had hit there it is. That was 1 o'clock in the morning. And we came to a stop because of the fact that we had hit this multi-year ice. It was filling in back behind the ship, and it was simply going to take too long. The ship has to slow down significantly to go through this ice. So you're only going about a knot, and it would take a lot of gas reserves and time to get through it. So that's as far as we got. We did some sampling, and then we turned around and started working our way back east through Lancaster Sound and such. This is actually the back side of the ship, and you can't even see a path. Usually when you're breaking ice, you have a nice clear path that's been made by the ship, and that was immediately filling in and then freezing back over. It was a fascinating thing to watch and to see the multi-year ice. As much as it meant we had to stop, it also meant, but it was great to see this type of ice in the Arctic, because this is actually one of the concerns where you have warming that's happening in the polar regions in the Arctic faster than that's happening around the globe. You're having your sea ice melt, and you're not seeing the multi-year ice. Its extent, how wide it's reaching is not as far, and how thick it is, it's actually getting thinner. And that's something really quickly, it kind of alludes back to the importance of why it's important to study the Arctic and why this research is important. And Alessandra, I don't know if really quickly you could talk about what that warming that's happening in the Arctic, what that feedback loop is, just so folks understand what is happening up there.
Yeah, sure. So as everybody knows, I mean, the global change is something that is happening, and it's happening very fast in the Arctic region, more than in other regions, and it's called the Arctic amplification. And it means that we have the last intergovernmental panel says that we are reaching more in the global scale 2.5 Celsius degrees more than in the past years. This means a lot because, for example, above all during the winter time, it's recording an increase of temperature around 3 Celsius degree. That it's an enormous amount. And also it's recording much more cloudy in the sky that brings more rains. So it's raining much more than snowing, even in winter time. So this means that for the equilibrium, I mean, we know that the climate system is made by the atmospheric cells and the interaction between the ocean circulations. So if this equilibrium is going to be, unbalanced, something will change. So this means that the ecosystem is changing, because in the Arctic, we will have much more meltwater runoff. So we will have much more bloom. For example, they were recording the double bloom also during the autumn. So this means that the completely ecosystem is going to change, and also the trophic chain will be changed. And also this means something that is changing all over the world, because we don't have to think that the Arctic is something very farther north, so we don't care about the Arctic or Antarctica, but everything is connected because the oceans are connected with each other, and the circulation, we know that in the poles there's the formation of dense water, and this brings it's a sort of refrigerating of the low latitudes. So this means that it's an equilibrium that was working because of the nature. But if we let for example, the greenhouse gases increase in the atmosphere, and we bring some artificial elements in the atmosphere or in the ocean, this equilibrium will shift. So this means that something will change, and is already changing. And this means something changes in the trophic chain, in the food chain. Everything is connected. So, we don't have to think that if we get pollution in Rhode Island, it's something that stays in Rhode Island, but it's something that is going around. And we saw this because when we went there, we were sampling for microplastics, for example, and we were finding a lot of plastics of each kind and shape, and a lot of microplastics, but we didn't look for nanoplastics. I will expect also nanoplastics there. And this means that the circulation we're bringing our pollution up to the Northwest Passage, that it's something that was completely enclosed and completely, I mean, unreachable until few years ago. So that's the point, that the Arctic is not staying in the Arctic. The Arctic is like a mirror, the Arctic and Antarctica, of course, a mirror of the globe. So we have to preserve, and each action that we do here, it's something that reflects at the poles and everywhere.
Yeah, no, that's great. They really are connected. And when you think about the feedbacks, you know, and the rapid warming, the ice is melting. The more ice that melts, the less of that white surface you have to reflect sunlight. So more sun is absorbed.
Also, the greenhouse exchange is going to increase, and also the sea level rise, and is rising already. I mean,
it's one of those things where it's very connected. Even though I know that the Arctic seems very far away for many folks, the three of us were really lucky in that we have been able to go up there and experience it. And I know we've actually experienced it multiple times, I think, between the three of us. We've been up in either poles, and it's just one of those things where even though it seems very remote, we're still very much connected. It's all one ocean, and the actions that you take here in Rhode Island or anywhere are really probably going to find their way to either of those poles. Kathy, before we wrap up, do you have any thoughts, maybe some homework in that sense of what can we do? What does studying the Arctic mean to you? Or what can we do here, do you think? I mean, there are some simple things, obviously, you know, you can go out and do a beach cleanup on Earth Day. But what are some other ideas or some activities that you've done or some resources you might want to share that folks could go look to?
Well, I know that we had talked about this earlier, but one of the things that it was really brought home with the Northwest Passage project and the ice coring is the microplastics making their way into what we think of as a pristine environment. And so to walk around your house and look at ingredients and look at bottles and cosmetics, especially, and things, personal items that have microplastics in them. And so to cut back on those, and mostly to be aware. I think the more we're aware we are of the interconnectedness, the more important it is. So my eco club at the high school has taken on the goal this past year of eliminating single-use water bottles, the plastic water bottles that everybody was bringing to school. So they wrote a grant, and we got water bottles for the entire school population. And unfortunately, because of the virus, we had to leave school early. So not everybody got their water bottles. But that's one change that the students brought about. And so I think that we have this group of students who are well aware of the environment and what needs to be done. And they're willing to make the change. And so to bring awareness to that, to bring the science to them, so they know that what they're doing actually makes a difference in the bigger world, is very important.
And I think that is a fantastic point to exit on, is that, you know, hopefully with all of you today that took a moment to tune in live, that you've learned a little bit, we've shared a little bit of our knowledge and our experiences. Maybe you feel a little more motivated. Definitely go check out, I'm sure that the web address for the Mosaic project, they have a lot of really fascinating data that's actually coming out in real time. There's, you can watch where there's a lot of interesting imagery, and there's a whole host of other resources that are available through that Mosaic project. And the Northwest Passage project will have a documentary that was filmed on board that will be coming out as well sometime within the next 6 months, perhaps to a year. It'll be available, so definitely check that out as well. But otherwise, thank you so much to Kathy, to Alessandra, for taking time out of your afternoons to chat with us today. Thank you to all of you that have tuned in. If there are other topics that you might be interested in to be involved in one of these GSO Ocean Classroom Live events, definitely type it in there in that comment box and let us know. So as we continue to plan out more of these events for the future, definitely follow along on social media with the Graduate School of Oceanography and the Inner Space Center. And then again, as well, Mosaic is out there on Twitter and posting different things as well. So look at those social media handles. And otherwise, Thank you so very much to everybody again. We hope you learned a little bit. Hopefully you're really excited about the Arctic. We all were. It was a fantastic experience, I know, for myself, and I'm sure for Alessandra and Kathy as well. It's something we'll always kind of hold close to our hearts as an experienced one to always remember. So everyone out there, continue to be well, be safe, and we'll chat with all of you again, I'm sure. Thank you so much. Bye, everybody.
Bye-bye.